Hi, everyone. My name is Nikita Manoj, and in this lecture, we're going to be learning all about two-way tables and how to analyze the data given to us in them. So let's get started. There's a few main things that we're going to be talking about in today's lecture. So first, we're going to talk about what exactly a two-way table is and how to identify the different variables that it represents. Then we'll move into talking about how to calculate different percentages based on the data in the table. And then we're going to learn what relative and conditional frequencies are. Don't worry if you don't know what those words mean yet. We're going to learn all about it in later slides. And then finally, we're just going to do a little bit of practice to solidify our knowledge of two-way tables. All right, so first, what exactly is a two-way table? A two-way table is a visual representation of the frequencies of two different categorical variables. So in this example, the two variables are the version of the commercial viewed and the opinion of the people who viewed it. One of these is represented in the rows and the other is represented in the columns. So in this example, the rows represent the opinions of the people who saw the commercial, whether they were likely to buy the product or unsure or unlikely to buy. And the columns represent each of the three versions of the commercial that were viewed. So there's version 1, version 2, and version 3. There's two important terms to note on the slide, which are joint frequency and marginal frequency. Joint frequency represents how many times a combination of two conditions happens. So it's literally where the two conditions join together or intersect. So for example, if we look at this first square that has the 25 in it, this is the quote unquote joining of likely to buy in version 1. So this point tells us that there were 25 respondents who were likely to buy the product after viewing version 1 of the commercial. The same logic can be applied to any of these 6 counts. All 6 of these represent joint frequencies. The next term is marginal frequency, which is just the entry in the total of the columns and of the rows. So everything in the red represents a marginal frequency. One important thing to note is that the sum of the marginal frequencies down here and in this right-hand column add up to the same number, 180. This number is found in the bottom right-hand corner of the table, and in every two-way table that you see, this number will represent the total amount of data points that you have in your table. So in this case, this tells us that there were 180 people total that responded to this survey. And this is important because the most frequent application of two-way tables, whether it's on a standardized test or even in real life, is to analyze survey results because it really shows you the relationship between the different variables. And this total number of respondents is really important when you're trying to pick out data in relationship to the whole group. Now that we know how to analyze a two-way table and what the different variables are, let's talk about analyzing frequencies. The first type of frequency we're going to talk about is relative frequency, which is the ratio of how often something happens to all of the possible outcomes. This is where this total number comes in handy because the relative frequency means that each of our data points will be used in a ratio with the total number of data counts that we have. And so that's represented by this 180. This information is used to find data of a group in relation to the total amount of people or counts of data represented, like I said in the previous slide. For example, if we wanted to find what percent of people were likely to buy the product after viewing version 2 of the commercial out of all of the respondents, we're going to look at likely to buy and version 2, which is this 20 right here. And then we're going to divide that by the number of total respondents, which is 180. And 20 divided by 180 is 0.11. And so if we want to find the percentage, we multiply that by 100 to get 11%. However, if we want to find data relative to a specific row or column, we're going to need to find the conditional frequency. So the conditional frequency represents the ratio of how often a certain condition occurs to the marginal total of that condition. So instead of using the total of the entire table, it's using one of these marginal totals specific to the row or column that you're analyzing. One important thing to note with conditional frequency is that depending on the marginal total you're using, the data value that you're finding represents a different thing. because the rows are representing one variable and the column is representing something else. So let's understand this concept through an example. I'm just going to use this data point right here, which is the joint frequency of unsure or unlikely to buy and version 1. So this 40 right here. So the marginal total of this column is 65, okay? So if we're gonna take the conditional frequency here, we take 40 over 65. This value tells us that out of the 65 people who viewed version 1 of the commercial, 40 of them were unsure or unlikely to buy the product. So in this case, this marginal total is in relation to how many people viewed version 1. So that's why this number tells us that out of the people who viewed version 1, 40 people were unsure or unlikely to buy the product. Now, if we move on to the opposite and let's look at this row, all right? This row total is 81, all right? And this is the total number of people who are unsure or unlikely to buy. So if we take the ratio of 40 over 81, this value tells us that out of the 81 people who are unsure or unlikely to buy any of the products, 40 of them decided that after watching version 1. So this value is given in relation to the opinion of whether or not they would buy the product. All right. So this is talking about how many people were unlikely to buy version 1 in relation to the total number of people in the whole survey that were unlikely to buy a product. Whereas in the first example, we're looking at the amount of people who are unsure or unlikely to buy the product after viewing version 1. So we're calculating the ratios of two different categories of data, which is why even though we use the same number 40, it's telling us two different things because we're analyzing a different one of the variables. All right, so now we've covered pretty much everything to know on two-way tables, so let's do some practice. Pause the video and try out these two questions and come back to check your work. All right, hopefully you guys paused the video and tried it on your own. Let's look at number 1. How many respondents were likely to buy version 2 of the product in the commercial? This is just asking us for the data count or just the numbers, so we don't have to do any taking ratios or making a percent. We're just analyzing the table. So it's asking us how many people were likely to buy version 2. So we're looking for the joint frequency of where likely to buy and version 2, quote unquote, intersect. So we have likely to buy, and we go over here to version 2. So that tells us that 20 respondents were likely to buy version 2 of the product after seeing version 2 of that commercial. How many people responded likely to buy and how many people responded unsure or unlikely? This is asking us for the total amount of people in each of these two categories of opinion. So we're looking for the total number of people who responded likely to buy. Well, that's in this total column right here in the row of likely to buy. So that tells us that 99 people in this survey responded that they were likely to buy the product. And unsure or unlikely, same thing, we go over. And 81 people responded unsure or unlikely to buy out of everyone in this survey. Now we have one more thing of practice. This one is going to be practicing frequencies. So once again, pause the video, try out these two questions and come back to check your work. All right, hopefully you guys pause the video and tried these out. Let's look at these two questions. So the first one is asking what percent of all respondents were unlikely to buy version 1? So when we see the words all respondents, we know that this is talking about the relative frequency because we're looking at the ratio of a certain category of data in relationship to the total number of people that responded. So we know that the denominator of our ratio is going to be 180 because that's how many people replied to the survey. And we're looking at the people who were unlikely to buy version 1. So we're looking at that joint frequency, which is right here. Unsure or unlikely to buy version 1, and that's 40 people. So when we're looking for the percent, we're going to take this joint frequency of 40 divided by the total number 180 and multiply it by 100, which gives us around 22.2%. And finally, for number 2, out of all of the viewers on version 3, what percent of them were likely to buy the product? We know that this one is asking us for a conditional frequency because it tells us specifically that we're looking for the amount of people out of all of the viewers on version 3, not out of the whole table, just out of version 3. So this is looking at a marginal total on version 3. The marginal total of version 3 is 85. So we know that that's going to be the denominator of this ratio. Then it's asking us what percent of them were likely to buy the product. So this is looking for the joint frequency of likely to buy in version 3. So when we go to likely to buy and move over to version 3, we see that that number is 54. So in order to calculate this percent, we're going to take 54 divided by 85, which is the total number of viewers on version 3, and multiply it by 100. And when we do that, we get around 63.53%. All right, guys, that's all I have for today. Thank you so much for listening, and I hope you have a wonderful day.